Welcome to the Fundamental Theorem of Calculus from pyfactory.net. We're going to call our input value t here, not x. So this is going to be our input. We could call it s, we could call it pretty well any letter. And we're going to think of it as a dummy variable. So our output from f is going to be f of t. And let's just sketch something in. On a closed interval between a and b. Closed a and b. This allows us to put in our closed interval between a and b our real variable x. And this, I hope, is going to explain some of the notation that we will see in a minute when we look at the Fundamental Theorem of Calculus. So our input is t, our output is f of t, this is f, our function, and x here is going to be a variable that goes inside our closed interval AB. First theorem of calculus. If f is continuous on the closed interval AB, then we're going to have an antiderivative, which we're going to call large f of x, between a lower bound of a and an upper bound of x, f of t dt. Notice that x as the upper bound. Here we see that our lower bound is a, and now our upper bound is a variable x, f of t dt. So large f of x is going to be the integral between a lower bound of a, upper bound of a variable x, f of t dt. So t here very much is a sort of a variable that's waiting, is an input waiting to receive this variable x here. So f has a derivative, so f has a derivative at every x in a and b. So the derivative of f is simply going to be the derivative of the antiderivative of f of t dt between a and x. So df, d large f of dx, is simply going to be f of x. This is the first fundamental theorem of calculus. So it tells us that every continuous function f is the derivative of some other function, large f, and every continuous function also has an antiderivative. And this tells us that integration and differentiation are inverse processes. This was the big breakthrough of the two sides, to link the two sides of calculus, differentiation and integration. The second fundamental theorem of calculus says that if f is continuous again on a closed interval AB, and if the antiderivative, large f, is any antiderivative of f, then the definite integral between a and b, definite integral between a, lower bound a, upper bound b, of f of x dx, is going to be a number, and it's going to be the definite integral at f of b subtract f of a. And the second fundamental theorem of calculus tells us that the definite integral of any continuous function can be found, which is good news, providing an antiderivative of f can be found. The fundamental theorem of calculus guarantees that the antiderivative exists, but unfortunately it doesn't always guarantee that we can find it.